Correlation is a concept related to the spread of data, if you were to put it on a graph. You see before you 5 different possible spreads of data, each of which can be labelled with a different type of correlation. First of all, with this one, where the data, as you can see, is more or less forming a straight line going from the bottom left up to the top right. Because it's going bottom left to top right, we're going to describe this as a positive correlation. And not only that, because it's forming almost a straight line, we're going to call this a strong positive correlation. In that same vein then, this data is definitely not as strong. It's not forming that close to a straight line. However, we can still tell that it's kind of going from bottom left to top right, so we'll call this a weak positive correlation. Thirdly now, it's none of the points are near each other in any kind of recognizable line. They're not going from any particular corner to any particular other corner. So in this kind of scenario, there would be no correlation at all. Then just down here, we're now going in the opposite direction. Once again, the points aren't massively close to each other, but we can still see they're kind of forming a trend. And it's going from the top left to the bottom right this time. So it's going to be a weak negative. And then finally, here, it's very close to forming a straight line again, and it's still going top left to bottom right, so this will be a strong negative. Now, once we've identified this type of correlation, and indeed the question you may be faced with, one part of it could simply be, what type of correlation is this? Positive, negative, strong, weak? You're maybe expected to plot a new point on there based on a line of best fits on your page. You would have to get a ruler, and you're trying to draw a line through the points such that either as many points as possible are got through, or as close as possible, equal number of points on either side of the line. Once there, say you could just plot on your line. So maybe if we go, this is more likely done with a strong correlation. So let's say we could put a point here, because that's going to be somewhere on the line, or here, or over in the strong negative. Maybe we could predict a point would appear here or appear there. We can't, however, use this same principle to predict a point that's, let's say, on the strong positive over to the right here, up in this even further corner. Now, even though the data obviously is still showing this straight line trend, we just don't know what happens when we get into these extreme values. We don't have any evidence for it. For all we know, if we just look down here in the bottom right of the screen, for all we know, the line could carry on like this, but maybe it levels off, or indeed curves back down. Because we just don't know, we can't say with any certainty what's going to happen. For points we'll say that are within the range of data that we have, like what we've done in green, we can fairly reliably predict those points. But because we just don't know what happens later on, we can't. Therefore, if you're ever asked, can you predict what will happen at this value, and that value is beyond any of the data that you have, your response will be something along the lines of, we can't know what will happen because that would be extrapolation. So we're looking at data that we just don't have evidence for, and we shouldn't be extrapolating. Alright, well, if we're happy with that, if we just turn to an example. Alright, so firstly for the correlation, we'll call it a strong negative. Negative because it's going from the top left to the bottom right, and as we can see, the points are more or less making a straight line as it is. And then just for the other parts, to work out what distance is going to be travelled at 2.5 litres, first of all, we're going to need a line of best fit. If this is actually on your exam paper, you'll use a ruler and a pencil. Again, there's going to be a little bit of leeway with what's allowed with a line of best fit, just depending on how you've drawn it. So long as I said before, your line either goes to the majority of the points or has an equal number of points on either side of it. Here then, if we just use my example, if we were to find where 2.5 litres is, it's going to be down here, follow it up to around here, and read across here. This would give us a distance of 11 kilometers. Again, so that will just be a little bit of wiggle room depending on how you drew your line. All right. Now for another example, just to work this one through, here we have another graph was looking at the number of units used. This is referring to electricity and heating as compared to the outside temperature. Molly says the average number of units of electricity used for heating decreases by 4 units for each degree C increase in outside temperature. So basically, the gradient of this line, the units used divided by the outside temperature, is going to have a value of -4. It's going down by 4 for every degree C that we go along. Part A is then asking, is Molly right? In order to work this out, we are therefore going to have to get the gradient. And in order to get the gradient, we're going to need another line of best fit. Going off here then, to work out a gradient of a straight line, you'll just pick 2 points on it. So let's say pick a point here and pick a point here at the two extremes. You'll then measure, well, how much have they gone up? How much have they gone across? And then divide that by each other. Look here, I can take that as approximately 85 and here as 35. Again, it will depend on your line of best fit and you'll be able to read a lot more accurately on your actual graph paper. But if we were to take that, so our 85 minus our 35 over, and here this is going to be 22, and 22 minus 0 is just going to be 22. This you can then plug into a calculator, so it's essentially 50 divided by 22, and this gets you a gradient of approximately 2.27, or minus. So is Molly right? No, because minus 2.27 is not the same as minus 4, so she is wrong. As for part B, so you should not use a line of best fit to predict the number of units of electricity used for heating when the outside temperature is 30 degrees C. Give one reason why. If we just think back to what I said at the beginning of the video, we cannot predict what's going to happen at 30 because we don't have any data here. The end of our data is at 20 degrees C. For all we know, this line of best fit, this trend will continue, but maybe it levels off, maybe it swings back up, maybe it plummets even more. We don't know. So basically, why should you not use it? Because you would be extrapolating. And we do not wish to extrapolate because that would make it an unreliable result.